Again, welcome to this class. And we want to talk about number systems. We want to talk about number systems. And this is a very, very important chapter within CCNA. And we are going to talk around 3 numbering systems. One number system is preferred by humans, and the others are preferred by machines. And so from the major objective, we'll calculate the number between decimals, binary, and hexadecimal. Numbers between decimals, binary, and hexadecimals. And we will start by calculating the numbers between decimals and binary systems, and binary back to decimal. We will also calculate the numbers between decimal and hexadecimal back to decimal. So this a lot of doing here, and I think it's important that you just get to participate. So we are going to get started. And in terms of getting started, I want to start by explaining that the binary numbering system consists of 2 numbers, just ones and zeros. Binary numbering system, the word bi means 2. So it consists of just ones and zeros. And they are what we call bits. Remember, today we are still on layer 1 of the OSI. And we say the PDU, the protocol data unit, at the layer 1 of OSI is bits. And the bits we have been talking about are bits of zeros and ones. So binary, 2 numbers, ones and zeros. The decimal numbering system consists of numbers from 0 through 9. 0 through 9. And 0 through 9 are actually 10 numbers. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So those ones are 10 numbers. And the word deci actually comes from 10. Deci comes from 10, 0 through 9. Now, it is important to note that host devices, which are our end devices, servers, including network equipment like routers and switches, they use the binary addressing to identify each other. And so each address is normally made up of 32 bits. And when we talk about bits, you should understand zeros and ones. So each address of any device is always made up of 32 bits. 32 bits. They can be zeros, they can be ones, they can be a combination of zeros and ones. Now, those 32 bits are always divided into 4 sections. 4 sections. So 32 divided by 4 is what? 8. Very good. So because the 32 are divided into 4 sections, ensuring that each section has 4 bits. I mean, each section has 8 bits. Sorry, each section has 8 bits. How do we call an 8-sided figure? 8-sided figure. Okay, let's start from a simple one. 3-sided figure. 3-sided figure?
Triangle.
Triangle. Yes. 3-sided figure is a triangle. 4-sided figure. All the 4-sided figure. We know that a rectangle has 4 sides, a square has 4 sides, even a parallelogram has 4 sides, even a rhombus has 4 sides. But we have a common name for all of them. We call them quadrilaterals. Quadrilaterals. So the word quad means 4. 5-sided figure. How do you call that? A figure with 5 sides.
Pentagon.
Pentagon. Pent. The word pent means 5. A figure with 6-sided figure. Hexagon. Hexagon. Good. A figure with 7-sided figure. Heptagon. Heptagon. A figure with 8-sided figure. Octagon. Octagon. Good. Now, that is where we generate. Yes, that's why we generate. We said that every address has 32 bits, and 32 bits are divided into 4 sections, leaving us with 8 bits per section. And that each section now, we call it an octet. Each section is going to be called an octet, simply because it has 8 bits. And we are going to deal with so much of it today. Now, so we can see each octet contains 8 bits, and 8 bits is equivalent to 1 byte. 8 bits is equivalent to 1 byte. Now, each of the 4 sections is always separated by a dot. By a dot. Each of the 4 sections is separated by a dot. We are going to see more of it. Now, for ease of use by people, the dotted decimal notations is always converted to dotted decimals. And so what I want to show you right now, is how we as humans, we see the addresses, and how does the machines see those addresses. I need someone to mute, please. There's someone who needs to mute. That person who needs to mute. Yeah, they already did. All right, so let's see this. Let's look at this. Let's start with how do we see those addresses. So this is how we see the addresses. Very organized, not bulky. When you look at, for example, this LAN network address is 192.168.10.0/24. The PC1 here has an address of 192.168.10.10. The interface of the router R1, G0/0/0, has an address of 192.168.10.1. And the G01 interface has 192.168.11.1. And PC2 has 192.168.11.10. And the whole of this network is 192.168.11.0/24. And the PC up here in the cloud has an IP of 209.165.200.225. Now, listen to this. Just like as humans, as citizens of a country, we need an identification number to be able to be referred to as the citizens of that country. The same thing, all these devices, for them to be citizens of the network, they must be able to have some identification numbers. Those numbers are called addresses. And here we have IP addresses. Is the first address we learned today. Now, it is very easier for us as humans or as network administrators to read these numbers. 209.165.200.225, 192.168.10.10. Very easy. Now let's see, how do the machines see these numbers? The machines see these numbers differently. And let me just show you the same numbers. Look at this. Same numbers, but seen from the eyes of the machines. Look at this. This is the number we saw as 192.168. This is .10.10. This is how the PC sees this number. This is, for example, the way the devices will see. This should be .11.10. Yes, 2 plus 4. Yes. So this is 192.168.11.10. Okay. And the 209 we saw is actually here. 209.165.200.225. So, ladies and gentlemen, one of the reasons why we come to this class is to not only see the numbers, how humans see them, but we also learn to have the eyes of a machine. And by the end of this lesson today, you'll have learned how to convert these bits of zeros and ones into decimal numbers, into the 192, 168, the 209.165. something. And that is one of the objectives we have everyone in this class. It is very hard for you to leave this class without understanding how to do this. So all of us, we will learn how we convert the decimal numbers to binary, because this is binary, and binary back to decimal. And that is one of the things we shall be doing today. So that is how the machine see it. In fact, the binary numbering system is also referred to as the machine numbering system, while the decimal numbering system is also referred to as the human numbering system, because we prefer the decimals, but machines prefer the binary. Machines prefer the binary. Now, ladies and gentlemen, I have some small knowledge of mathematics, and I will make sure today that all of us understand this mathematics. It is not a very hard maths, it's very easy. And the good news is that with my good background in teaching, I'm going to start us from class 1, and we come all the way through primary, we come to high school until we get to the university. Now, we're going to start. Do not underestimate how I'm going to start. It is very easy to underestimate, and yet you shouldn't underestimate it. Now, we'll start very simple with we'll start very simple with we're going to start very simple with just multiples of 2. And we'll do addition, and we'll also do multiplication. But let's start from somewhere. We'll start with multiples of 2. So we'll start with, what is 2 raised to power 0? Is 0, isn't it? Yes, and we should know that any number raised to power 0. What is 2 raised to power 0? Should be 1, okay? Yes. Any number raised to power 0 should be 1. Even 1 million raised to power 0 should be 1. 2 raised to power 0 should be 1. 10 raised to power 0 should be 1. So any number raised to power 0 will always be 1. That is a mathematical rule. So we have seen 2 raised to power 0 is 1. 2 raised to power 1 is 2. So any number raised to power 1 is that number. Okay? Any number raised to power 1 is that number. And no wonder even 2 raised to power 1 is 2. All right. 2 raised to power 2 is 4. 2 raised to power 3 is 8. 2 raised to power 4, 16. 2 raised to power 5, 32. 2 raised to power 6, 64. 2 raised to power 7. So today we are going to just stop there. We are going to have to know 2 raised to power 0 all the way to 2 raised to power 7. And our learning, if you are not sure of any of those numbers, our learning is going to revolve around them. And we will need to have to know from 2 raised to power 0 up to 2 raised to power 7, and from 2 raised to power 7 all the way to 2 raised to power 0. And I'm going to present a blank page here, and you people are going to tell me. Let's do it one more time, maybe because we are still seeing it on the board. So let's start. 2 raised to power 0, 1. 2 raised to power 1, 2. 2 raised to power 2, 4. 2 raised to power 3, 8. 2 raised to power 4, 16. 2 raised to power 5, 32. 2 raised to power 6, 64. 2 raised to power 7, and 28. That is well done. Now let's go. 2 raised to power 7, 28. 2 raised to power 6, 64. 2 raised to power 5, 32. 2 raised to power 4, 16. 2 raised to power 3, 2 raised to power 2, 4. 2 raised to power 1, 2. 2 raised to power 0, 1, isn't it? Yes. So For a long time, one of the tools that has helped me to teach this class is this my simple notepad here. This notepad is very powerful and it's going to help us so much. Can you see those numbers? Or someone cannot see? Peter, can you see those numbers? Okay. All right. So let's see. So all right. So let's see. So 2 raised to power 7. Okay. Let me just write 7. Okay. Give me 2 raised to power 7 was 128. 2 raised to power 64. 32. 16. 8. 4. 2. 1. Okay. Very good. We are going to deal these numbers, by the way. Do you remember when I said each section, okay, the total number of bits in every address is 128, is 32, isn't it? But the 32 bits are divided into 4 sections, isn't it? And each section has how many now? 8 bits. Each section has 8 bits. Okay? So if each section has 8 bits and we call it an octet, okay? How many numbers are these ones on the screen? There are also 8, isn't it? There's a very strong reason why. And each of the bits in the section, each of the 8 is always represented by these numbers. Okay? Yes, from left to right. And of course, we are going to see that. But for now, I want us to learn how to add these numbers. It's going to be very important. So let's go. By the way, try to keep your calculator very far away. Otherwise, you will not learn. Let's go. We are starting to add from right to left. 1 plus 2, 3. 3 plus 4, 7. 7 plus 8, 15. If you are attending online, please do it by yourself. Otherwise, a time will come when it will be between you and your God and you won't manage it. So let's start again. 1 plus 2, 3. 3 plus 4, 3. 7. 7. Good. 7 plus 8, 15. Because of guys who are online, because of echo and all that, you might want to say in your heart, not everyone has to talk. It's okay if one person talks, but because of echo issues, but make sure you're also doing, even if it is silently. We were at 15, which was 7 plus 8, isn't it? 15 plus 16, 31. 31 plus 32, 63. 63 plus 64, 127. 127 plus 128. Should be 255, isn't it? Yes, the total is supposed to be 255. So 1 plus 2, 3. 3 plus 4, 7 plus 8, 15 plus 16, 31 plus 32, 63. Okay, 63 plus 64, 127, isn't it? 127 plus 128, 255. Okay, yes. Let's go now from the other end. 128 plus 64. Use your pen and paper. 128 plus 64. 192. 128 plus 64 is 192. Yeah. 128 plus 64 is 192. Yes. You know, in the initial days, there were no calculators. So people used to do maths. Like in Saitoti, they used to do maths just by pen and paper. And I'm taking you back to the roots because that's where mathematics started. We don't want you to cram anything. We just want you to master, and we just want you to at least get them from memory. So we have said 128 plus 64 is 192, isn't it? 192 plus 32, 224. Okay? 192 plus 32 is 224. Okay? Okay. 224 plus 16. 240. 240 plus 8. 248. 248 plus 4. 52. 252 plus 2. 254. 254 plus 1. 255. Now these numbers are very important. In fact, we are going to meet them somewhere. You're going to meet them somewhere in that particular arrangement, but you must be able to know them. And that's why I want us to do it again. And I'm going to remove these ones here. We are starting. And if you have written them down, just try to close your book now because you have already seen them. Yes, I'm going to make it as memorizing as possible. I want you to say memorial. So 128 plus 64. 192. 192 plus 32. 224. 224 plus 16. 240. 240 plus 8. 248 plus 4. 252. 252 plus 2. 254. 254 plus 1. 255. So those ones are very important. So something that I want us to learn to do by the end of today again is marking those numbers. So if 128 plus 64 is 192, and the first number is 128, so I can be able to have something like 128, 192, 224, 240, 248, 252, 254, 255, 128, 192. I'm adding them like that, but I start by mentioning 128. I add 64, I add 32, just like that. So 128, 192, 224, 240, 248, 252, 254, 255. 128, 192, 224, 240, 248, 252, 254, 255. I didn't tell you it will be easy, but trust me, it will be manageable. It will be manageable because I want someone to try. Someone to try. 128, 192, 224, 240, 248, 252, 254, 255. 128, 192, 224, 240, 248, 252, 254, 255. Mercy wants to start. 20 cards. Let's go. 40. 55. Okay, someone else? Right? 92, 24, 40, 50, 48, 52, 54, 55. Okay, let's go. Someone else. Boss, you want to go? 128, 192, 224, 240, 248, 252, 254, 255. Okay, we have finished this side. Now we are this side and then we go online. Boss, you look like you want to go next. Peter? 128, 192, 224, 240, 248, 252, 254, 55. Charles, you are 128, 192, 224, 240, 248, 252, 254, 55. Thank you so much. Yeah, let's go. Let me get people from the call. Someone just unmute and start, please. We do not have so much time.
One 128.
Good.
192.
Good.
224.
24.
240.
240.
248.
248.
252.
252.
254.
254.
255.
255. Wonderful. Someone else? Someone else? Anyone who is burning to try?
128.
128.
192.
92.
192. 224. 240. 248.
Good.
252. 254. 255.
Perfect, perfect, perfect. And anyone? Anyone else? I don't want to cut anyone who wants to try. Resist the temptation not to want to try. Keep on trying. We're all learning. All right, all right. I'm assuming those people are trying quietly. Anyway, you will be glad that you know those numbers. Trust me. As time moves by, you'll be glad that you know those numbers. Yeah. All right. And so if you start from the left, it's harder initially and it gets easier as you finish. But if you start from the right, it's very easy initially and it gets harder to finish. So 1 plus 2 is 3, 3 plus 4 is 7, plus 8, 15, plus 16 is 31, plus 32, 63, plus 64, 27, plus 128 is 255. Okay. Good, 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 good. That's done. That is wonderfully done. Now, so I'm actually using 2 slides here for my teaching, and you guys will bear with me. Keep on switching. Anyway, let's go on. And the next thing that I want us to start now, since we have already known those numbers, is here. So the first thing that we actually want to do right now is very simple, is that we want to, looking on the board here, we want to start by converting when you're given a binary to decimal, okay? Yes, like we said, the binary will always be 8. They will always be 8. When you convert them, you'll convert them into a certain decimal number. So this is how we want to start now. And it's very simple. The first conversion is normally very, very simple. And this is because in converting from binary decimal, so to start us off, let me just get a pointer here. So this is actually the binary that we want to convert. You can see it here. It's 11000000 dot 10101000 dot 00000011 dot 00011010. We want to convert this binary to decimal. So easy. I want you to just first look how we do it because it's not hard. And in terms of how we do it, the first thing we are going to have is that, can you see our numbers here? Yes, 1, 2, 4, 8, 16, 32, 64, 128, and we start writing them from right to left. The 128 is on the right. Don't start with 1, 1, 2, all the way to 128, okay? So we want to convert the first octet. We said an octet has 8 bits, isn't it? Yes, can be all zeros, can be all ones, or a combination. So we want to take 11000000, and we are going to put it here. Can you see it here? Yes, we put them below each and every of those numbers. And so we start from left to right. So the first one will be under 8. The second bit is under 64. The third one is under 32, under 16, under 8, 4, 2, 1. We are together up to there, isn't it? Very good. So the next thing that we do, it's very simple. We just multiply 1 times 128. What do we get? We get 128. 1 times 64? 64. 0 times 32? 0, isn't it? Yes. And 0 times 16? 0. 0 times 8? Of course, these ones are all zeros. So 0 times any number is 0, isn't it? Once you have multiplied them, we just add the numbers. So what is 128 plus 64? Eh? Yes, I want that one to be borrowed knowledge because we already, that is where we were adding those numbers. And now you should be able to know that 128 plus 64, you don't even have to think. Those ones, I need them to be at your fingertips. So 128 plus 64 is 192, plus all these other zeros, the answer is still 192, isn't it? Good, we take the second one, which is the second octet is here, 10101000. Again, we put them here. Under this 128, 64, those are our magic numbers. So sometimes, because I want to make it much easier, if you're given the 8 of them, it's like you just choose where there's a 1. That's what you multiply. Is that okay? Yes. You just look where there's a 1. That is what you multiply after, because 0 will still give you a 0, isn't it? So we have a 1 under 128. Good. The next one is under 32, and that is the 2 here. The next one is under 8, and there's no more 1, isn't it? It's like we're adding 128 plus 32, 168. And that is the other thing I wanted to tell you. You need to know how to add those numbers. They don't have to follow each other. You need to know what is 128 plus 32. What is 128 plus 1? Okay? Yes. And this is the only class where there's also a game. We are going to play a game, which is part and parcel of learning today. And I'm going to require everyone to access a computer where you can be able to log in. You're going to log in. That game is inside your account. You're going to log in, and I'm going to give you 15 minutes of playing. Okay? 15 minutes of playing. And with that game, I'm going to put a bet. Okay? I'm going to put a bet. Yeah. That game, when you get to level 4 of the game, I'm having 1,000 bob, 1K for anyone, even if it's all of you, even if it's those who are online. If you're online and you reach level 4, you just need to take a screenshot, and I will know if you distributed your screenshot to so many people. Anyway, let me not say that first. Let's learn first. All right. So we were taking the second one, okay, the third one, and we had already gotten 128 plus 32. What can that be? 160. 160 plus 8? 168. And here is our 168, isn't it? Are we together, guys? Make sure when I'm faster, you slow me down. The third one is 00001011. Okay? Again, we put them here, down there. 00001011. And the first one is under 8. So it's like 8 plus. The next one is under 2. And the last one is under 1. So 8 plus 2 plus 1 is 11. And we have 11 here, isn't it? The last one is 10. And it is actually 00001010. And this is the other thing that I want you to tell me. Once you know, look at this. Look at this. Once you know this 0 is 0, 0, 0, 0, 1, 0, 1, 0. I want you to tell me something. I'm trying to make you to be fast learners here. At this point, you should know that the first 0 represents which number? 128. The second one? 64. The third one? 32. The next one? 16. So the 1 represents? 8. The 0? 4. The 1? 2. The 0? Yes. So if you want to do it faster, you can just locate the positions of the ones and you add those numbers so that you work faster. Okay? Yes. Even if you start from this other end, you know this is 1, 2, 4, 8, 16, 32, 64, 128. Okay? If you can know those positions, it will help you to work much faster because we want to do the reverse. Of course, you can see that the lower one here is just 2 plus 8, and that is going to give us 10, isn't it? Yes. So the whole address will now be 192.168.11.10. That is so simple, converting from binary to decimal. And now we want to see how can we move from decimal back to binary. Okay? Yes. How can you move from decimal back to binary? Is there any challenge you have with that? That will not have challenge, but in case there is a challenge, make sure you let me know. So we have converted from binary to decimal, just like that. So if I give you some examples, you can work on them very fast. I will give you examples. So let's go the other way around. Let's do the other way around. And we now want to convert from decimal back to binary. And with this one, I'm going to use another. I think I should give you some. Let me see if I can give you some few here. I see what you can be able to do. So this is an illustration here for doing conversion from binary to decimal, and we can actually work it out. So this one, ladies and gentlemen, is an activity which is found right inside your account. And we use it for converting from binary to decimal. I believe you can see it. And so we have our binaries here. Can you see them?
Yes.
Good. And we need to get the answer of the binary of the decimal value here. So this is 128 plus, where there's a 1, you add the numbers that are up here. Are we together? So 128 plus 64, what is that? 192 plus 32, 24 plus 16, 240. 240 plus 4, because under 80 there's a 0, isn't it?
44.
So 244. 244 plus 2 plus 2, 246. So our answer here, we write 246, and then we click check, and it tells us the decimal value we have entered is correct. Please click new number. Like I said, show me is for lazy people. I've never taught a lazy people in my life ever since. So do not even dare, okay? So we click new number, and we see they bring a new number here. So here is a new binary here. This is now 128 plus, what is that? 160. 160 plus 8. What is that? So our number is 168. Those ones are very easy. Check. Correct. Let me click new number again. Give me that. I just want you to give me the answer now. I want to put it up here because now we have seen how to do it. You can do with your pen there, pen and paper there. So 64 plus 32 is what? Huh? The answer is 105. 107 or 105? What is 64 plus 32? 90? 96. Very good. 96 plus 8. Yeah? 96 plus 8. 104. Sindio? 104 plus 1 is 105. Yes. That's how we do it here. Let me get another one. New number. Check this out. So 128 plus 64. 192 plus 32. 224 plus 16. 240. 240 plus 2. That is very easy. 242. So those who did that numbers now, we are finding them. Those who did it well. All right, let me do maybe few of them. Check that out. 128 plus 32. 160. 160 plus 8. 168 plus 4. 172. I want to look for 1 here. Good. That is well done. Let me click new number. What is that? 128. Very good. Give me this one here. New number. Check that out. Check that out. 128 plus 16. You need to know to add any number to any number. 128 plus 16. I want you the pen and paper working. Please resist the temptation to use a calculator because it will give you more harm. 128 plus 16 is 144, eh? 144 plus 8. 152 plus 1. Eh? 155. Good. I'm looking for a tough one. This one? 188 plus? 188 plus? 1? 142 or 144? 44. Good. This one? This one? 49. Sindio? Because 32 plus 16 is 48, isn't it? Yes. 49, eh? And what is this one? 7. 4 plus 2 plus 1. It's 7, isn't it? Yes. Check. This one? 16. Very good. What about this one?
25.
What about that one? 255, isn't it? When all of them are ones, it's 255. Okay. Yes. Let me ask you. Check this out. Check this out. What if all these ones are one? Only this one is 0. What could it have been?
127.
Eh?
127.
Should be 127. If you add 1, 2, 4, 8, 16, 32, 64 is 127. Then 127 plus 128 is 255, isn't it? Check this out. What if we have what if we have these two are zeros? 2? It's like you minus 255 minus 6. 249, isn't it? Yes. Hey, anyway, that time will come. That time will come. I will give you this one. You can play around with it because we're going to be playing this until we get to chapter 10, chapter 11 actually. Anyway, that's okay. Let's now see how can we do it the other way around. And with this one, I'm going to go straight into the activity here because I realized people learn better through this activity here. So check this out. This is how we want to convert from decimal back to binary. From decimal back to binary. You people are very sharp students, so that's why I'm teaching you this method. You see the decimal we have been given is what? 8, isn't it? We want to convert it to binary down there. Okay? So the rule is simple. You need to find which numbers among the numbers here. You see these numbers here? Yeah? You need to ask yourself, which of those numbers, if I add them, I get 8. Which numbers, if I add, I get 8? Between 1, 2, 4, 8, 16, 32, 64, 128. Yeah? It's only 8. It's only 8, isn't it? Are we together? Yes. So I just put 1 under 8, and the rest I put zeros. And that is the binary. Are we together? Yes. This is a bit simpler. I want us to get one where we need to scratch our head a bit. So this is actually simple. Let me get a new one. Even this one looks simple. 63. Is it familiar? Have you mentioned this number today? 63.
Yes.
Eh? Have you mentioned 63 today? Which numbers did you add to get 63? Yeah, because I forgot to tell you something. We added 1 plus 2 is 3, isn't it? 3 plus 4? 7. Okay. Now listen to this. Do you realize if I add 1 plus 2 is 3, isn't it? You always get the next number minus 1. 1 plus 2 is 3. 3 is 4 minus 1, isn't it? 3 plus 4? 7. 7 is 8 minus 1, isn't it? 7 plus 8? 15. 15 is actually 16 minus. So if you add, you don't just get the next number minus 1. That's if you see 63, it means it refers to 64 minus 1. Okay? It actually means it is all these numbers are ones, and the only place you put zeros is at 128 and 64. Otherwise, from 32 onwards, all of them will be 1. I don't know that I'm clear. I want to teach you another method, but that method is very long. As mathematicians, we are always very brief. We do not want to make things very complicated. So this was very simple. So 63 is actually a number we need to know it because it is 1, 2, 4, 8, 16, 32. If you add them, you get 63. Okay? Let's get another one. 243. This is an interesting one. And when you meet an interesting number like this, I want to give you some rules that will help you. Okay? So the first rule is this, and I want you to do it if you have pen and paper. So the first rule, if you're given a big number, Okay. First, start by minusing the biggest number within our list here. So can you minus 243 minus 128, which is the largest? Please subtract 243 minus 128. You get 115. Get 115. If that number is still larger, because our objective is 1, reduce the number until you can be able to find numbers you can easily add to get the answer. So again, subtract 64. If you subtract 64, what do you get? You get 50. 51, isn't it? Yes, you get 51. We can still be able to subtract 32. If you minus 32, what do you get? 19, isn't it? 19 is what plus what? Among these numbers here, what do you add to get 19? You know, 8 plus 4 is? No, actually, you start from here. 16. We have 19, isn't it? What do you add to 16 to get 19?
+4.
We have 19, isn't it? We know that 19 is 16 plus something. 16 plus 3, isn't it? But 3 is 2 plus 1,
Yes.
isn't it? Which means 19 will
Yes.
be 16 to 1, isn't it? Yes. So the objective. So look here. So we started by minusing 128. Put a 1 there, isn't it? Again, we minused 64. So we put 1 there. We also minus 32. And at that point, we remained with 19, isn't it? Did we remain with the 19? And 19, we have said it is 16 plus 2 plus 1. And the rest now you fill with fill in with 0. So the objective is to get numbers that you can add to get that number, and the remaining spaces you fill them with zeros. It will come. It looks a bit complicated initially, but trust me, I am the best teacher in teaching this one. You don't want to know that. Let's go to another one. 148. 148. Check this out. Look at this. Look at this. Don't even write. We have 148. 148. But our first number among the magic numbers is 128. Do you know it is easy to subtract 148 minus 128? What is it? 20, isn't it? So we put 1 under 128, and then we ask ourselves, which numbers do we add to get 20? 16 and 4. I don't know whether we are clear, because I want us to be clear. So familiarity with the numbers is very important. If I see a number like 148, 128, of course I can subtract them. It is easy to subtract 148 minus 128 because we know there's an 8 somewhere, isn't it? So I just need to subtract 40 and 20 and I get 20, isn't it? So once I get which numbers I can add, then the rest I fill with what? With zeros. And this is my binary. This is my binary. If you have a question, you must ask me a question, please. You're not, when you go home today, even in the streets of Nairobi, you're going to ask no one these questions and they answer you. I'm the only one who will answer you these questions now. Look at that. 214. 214. So the first thing we do is to subtract what? Subtract 128. So what answer do you get? When you subtract 128, put 1 under 128. Give me the answer. 214 minus 128. Yeah? You get 86, isn't it? And looking at 86, what is 86 minus 64? Yeah? 22. So put what under that? So 22. So we are looking for a number that if you add, numbers that if you add, you get 22. Of course, 16 will be there. See, 16 will be there. So what is 22 minus 16? Eh? 22 minus 16? 6. So we put 1 at 16. So we remain with 6. Which numbers if you add, you get 6? 4 and 2. And the rest are going to be zeros. The rest are now going to be zeros. So that's how it. So we started the 214. We subtract the largest number, which is 128. We remain with 86. 86 minus 64. The answer was 22. Then 22 is actually 16 plus 4, which is 20, plus 2, which is 22. Okay. In fact, sometimes you can break it down. If you see 22, you say 22 is actually 16 plus 4 is 20. We know that. Then to get to 22, we just need to add 2. So the rest will be like that. 238, another one. We start by subtracting 128. So look at 128, 238. 238 minus 128? Eh? 110, very good. So we have 110. And in 110, minus 64, what is that? Eh? 46, so we are having 46. Now, 46, we need to know which numbers can we add to get 46? Or we can still subtract 32. 46 minus 32? 14. Which numbers if you add to get 14? 8 plus 4 plus 2. 8 plus 4 is 12 plus 2, 14. Then the rest you fill with zeros. We just do it slowly by slowly. It will get in. Let's do probably the last one. This should be easy. 125. It was very close to 128, but it is not. So we minus 64. What do we get? Good. Good. We have 61. 61, we need to minus 32. What is 61 minus 32? 29. 29 now is a number minus 16, we get 13, isn't it? 13 minus 8, 5. 4 plus 1. Very good. And the rest is going to be zeros. 0. So you see how we play around with the numbers, Yes, it's very, very important. You know, it's 6:30 and 6:34. 6:30 is the time we were supposed to start playing the binary game. So I'm giving you a few minutes. Can you log into that computer you're seated in front, please? Yeah, well, to do that, please log into your machine. You're gonna log into your machine, to your account, and you log in, you go to page 5110. 5110. Yeah. Did you manage to log in to the computer first? Yes. Okay. Okay. There's another machine loading here. You see 5110. 5110. Anyway, everyone, those who are logging on the call, please log into your account. So yeah. Again. 110. If you log in. Yeah. 5110. 5110. Yes. 5110. Anyone who's having challenges in logging in? Anyone who's having challenges in logging in? So check the instruction with this. I think the invitation. So good. Just click on anybody can post on. Anyone can. Anyone can post on. It's coming. 5.10. And 1. All right, so let me just do a small demonstration here, and then we start that game. And then we start. So, you 5110 brings you to the binary game, and you're gonna have to click on this link here, and when you click on the link, it's 5110. So it will bring this link here, and you're gonna just need to say play the binary game. Play the binary game. And so this is how the game is played. Yeah? Let me give you, before you start playing, we are going to have about 15 minutes of play. I'm assuming everyone has logged in. So when you, of course, the instructions are here, but because I know the instructions overhead, I've been playing this over and over. So when we start, let's look up. When you start, your objective is 1, okay? You see the numbers are up here, 1, 2, all the way to 128. Eh? They are up and they are down there. So your objective, 2 things. If the number is here, you're gonna ask yourself, which numbers if I add, I get 2? It's 2, isn't it? So I click 2 here, the number be under 2, I click 2, but remove this one. Where there's 4, remove it, and then that will disappear, okay? This is 5. 5 is what plus what? 4 plus 1. So click 1, the number under 1, and click the one under 4, and it disappears. Then if there's a question mark here, okay? If there's a question mark here, click on it, and so the number that is here, this one is, what number is found below it? 16, okay? So you can type with your fingers on the keyboard, or you just click. Clicking might be slower, but you can just type 16. And then you can click tick here, or you just press enter, and it will go, so that you go faster, because the screen is going to fill up. When it fills up, it's going to start blinking on you, okay? The objective is to get to level what? Level 4, okay? Yes. So right now, this is 1 plus 2, which is 3. So I just click there and I move on. This is 8. So 8 should be 8. So put it here. 32 here. This is question mark is 128 plus 1 is 129. Press enter. And so I need you guys to start playing now. 5110. Yes. Yeah. So keep on playing. Please don't play. Good. Keep on playing. On playing. On moving on. And use the keyboard and use the mouse, whatever it is you want. And let me just do the timer so that you don't go overboard. We're having 15 minutes, and your 15 minutes is going to end at, yeah, I think we can play for, because we'll only be having one more thing to do. We can play for the next 20 minutes until exactly 7. Till exactly 7. That's enough time. Keep on playing. We will stop at exactly 7. And it will get at a time when you reach some level there, they will remove the numbers on top and the numbers below there. On play. And as you play them, as they continue filling the screen, you don't have to start with the lower and the uppers. Just do it randomly, whichever that you can be able to figure out fast. This is that's keep on moving, guys. Keep on moving. Keep on moving, keep on moving.
Yes, yes.
That's your hope that.
Yes. All people know this is setting up. For the easy. It's Let's finish level 4. Finish level 4.
Anyone? Anyone online? Finish level 4. Anyone finish level 4? Level 4. Finish up level 4. We have 10 minutes. 10 minutes. 10 minutes. Go. Minutes to go. Anyone finish level 4? Finish your level 4. Finish. Anyone finishing level 4? Can pause it if it's very hot. It gets very, it brings tension sometimes. And you see it's going to fill up. Yeah, just to restart. Yeah. Yeah, that game is a game that I'm gonna need you to play it. We play it until chapter 11. Chapter 11 will be very easy for you if you keep on playing that game. Keep on playing that game. Eh?
Game over.
Game over. Eh? And it's just adding the 8 numbers. That's all that we're doing. We're adding 1, 2, 4, 8, 16, 32, 64, 128.
Game over. Game over. We check the scores.
You know, it's almost not. You finished level 4.
Check the highest score. Yeah, check the highest score.
You know, this game, it is anyone finishing level 4 only.
Go for it.
Don't, so long as it finishes level 4 and it's going to level 5, that's it. I have a few points here. I have a few notes here. And some I can send for them.
For the highest score.
Who's finished level 4?
No.
This guy was at level 3. Yeah?
I was nine.
Did you finish level 4? Because you have some. Yes, please just start again. If it's game over, I want you to play the second time because you have 8 minutes. So if anyone on the call, if game over, please play it. We still have, I'm giving another chance. I'm giving another chance to redeem yourself. Giving you another chance to redeem yourself. Please play the second round. We are stopping the next 6 minutes. 6 minutes. Wow. Stopping time. I have a few notes here. Tired of carrying them. Can give to someone. Anyone interested? Let's finish with level 4. Yeah.
Cosa no?
finished level 7. Those guys are done. Level 1. Level 4. Level 4. Did you finish level 4? I was waiting to finish level 4 one. Peter, level 4. You finished? Almost. It's almost.
This course.
This guy very finished level 4. Level? Finished. You did finish. You're trying. Anyone online who finished level 4? Anyone? There's a guy here who finished level 4. So he's saying, I am going to be broke. Minus 1,000. So let me just so can you send it to the group? No, don't send it to the group. Those guys, someone can edit it. Yes. So show me again. Huh? Almost. So you people didn't finish level 4. You have disappointed me, man. You have made me to go home rich, man. That's so bad. Anyway, guys, keep on trying. Trust me, you're not the way you came today, isn't it? Yes, ime chokora akili. It's made the brain to some maths. Anyway, that's okay. That's okay. And so let me just pause this and hope guys have played it. It's I even added you 8 more minutes. So that's okay. That's okay. Let's do one more thing before we get going. In the next 22 minutes, we should be gone. In the next 22 minutes, we should be gone. Let me just finish up the part that is remaining here for us to move on. And so all this is there. So now let's look at look at the board now. Let's look at the board. So like we said, we have been converting decimal to binary, and we've also converted binary back to decimal, isn't it? Good. Now, routers and computers and switches, they only understand the binary. Humans work with decimals, and you have seen it, isn't it? Yes, we love working the decimals. So it's important for us to gain a thorough understanding of these two numbering systems and how they're used in networking, because that is networking. If you ever go through a networking class and someone never taught you binary and decimal, that is not networking. So the thing is, we see 192.168.10.10. The machine see the binary that you see down there, okay? Yes, and that is exactly how it is. So now we go to the last numbering system, which is going to borrow the two of them, the two numbering system. It's going to borrow binary and it's borrow decimal. So this numbering system is called hexadecimal. This numbering system is called hexadecimal numbering system. Now, we said a 6-sided figure was called hexagon. 6-sided figure is called hexagon, which means the hex there is 6. Okay? Hexa is 6. What about deci? Deci is how many numbers? Huh? 8 decimals. 10, isn't it? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Those ones are 10, okay? Which means this numbering system, hexadecimal, contains 6 numbers and another 10 numbers. 6 for hexa and 10 for deci. And that makes it a total of 6 plus 10 is 16, okay? So this numbering system contains 16 numbers. It's a numbering system with 16 numbers. And we are actually going to see those 16 numbering. Let me use another slide just to be able to make it simpler for you guys. All right. So here we go. Okay, so Finish at 7:30. So they'll finish fast. Okay. So what will I will just yeah. All right. So this is the these are the 16 hexadecimal number, the hexadecimal numbering system. I can just let me erase this. Let me see what that is. All right. So these are the 16 numbers among the hexadecimal numbering system. And let me just get my marker here. So these are the decimals here, 0 up to 9. But among the hexadecimal numbering system, like I said, we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? After 9, the next number is A. So A, B, C, D, E, F. There's no G. So it is 0 up to 9 and A up to F, where A represents 10, B represents 11, C represents 12, D represents 13, E represents 14, and F represents 15. F represents 15. F is not 15. Are we together? You cannot say that the last number of the hexadecimal numbers is 15. No. F simply represents 15. But 10 is not a hexadecimal number. F is a hexadecimal number. A, B, C, D, E, F. Those ones are hexadecimal numbers. Now, it is very interesting the way this numbering system works. Very, very interesting. And so, one more thing I want to emphasize is here. Let me bring my notepad again, right here. So check this out. Check this out. We saw that these numbers were 8. We said so, isn't it? Yes, these numbers were 8, 1, 2, 4, 8, 16, 32, 64, and 128. These numbers are actually 8. So when we are the addressing that we were using in IPv4, I mean the one we are using those addresses, there were always how many binaries? How many binaries were in each octet? Each octet was having how many binaries? Yeah? Octet. 8 bits, isn't it?
8.
Yes.
Yes.
Yeah, a total of 32 divided into 444. I mean, divided into 4 sections, and each section was having 8 bits, and that's why we called it an octet. We called it an octet, and that is also why. Look at this. These ones are called octet here. Well, the first one is the first octet, second octet, third octet, and fourth octet. We start numbering them from left. This is the first octet, second octet, third octet, and fourth octet. Each octet can only have 8 bits. And those bits can be all zeros, can be all ones, or they can be a combination of zeros and ones. Very, very important. Now, so an octet will never have 9 bits, and will never have 7 bits. It must have exactly 8, okay? So I want you to check this out. Check something out here on my notepad. In the previous one, we were using numbers 1, 2, 4, 8, 16, 32, 64, 128. The next one is even very simple, because in the next one, we'll only use 8421. Are we together? In the next one, we are only going to use 8421. So instead of having 1, 2, 4, 8, 16, 32, 64, 128, we're only going to have 8421. And for example, check this out. If you have a number like 4, okay? You know, 4 is one of the hexadecimal numbers, isn't it? Are we together? Because hexadecimal numbers start from 0, 1, 2, 4, 8. No, it's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. A, B, C, D, E, F, okay? Where A represents 10, B, 11, C, 12, D, 13, E, 14, and F is 15, okay? So if I have a number like, check this out. I want you to see it. If you don't look up, you won't see it. Let's say we have a number like 5. 5. Okay. Which numbers here do we add to, and we get 5? 4 and 1, isn't it? Which means under 8, there's a 0. Under 4, put a 1. Under 2, put 0. And under 1, you put a 1. So 5 written in hexadecimal, written in 5, which is hexadecimal, converted to binary, we'll get 0, 1, 0, 1. I want you to see it. We have changed a bit. Now we don't have to use up to 128. We only use the smallest 4, the last 4, which is 8421. Okay? So if you have a number like 5, 5 is just 4 plus 1, which is 5, isn't it? Very good. Check this out. 13. 8, 4 plus 1, isn't it? So our decimal, our binary will be 1101. Can you feel that it's easier to work with 8421 than if you have up to 128? Because the highest number you can get here is what? If you add 8421, what do you get? 8 plus 4 plus 2 plus 1? 15. Imagine the highest number you can ever be given is 15. The other one, the highest number is 255. So it's easier to work with 15 coming downwards, isn't it? Good. So this is going to be 13. Is what? Eh? Yes. I get you. It's actually supposed to be D, which is equivalent to? It's equivalent to 13. That's how we write equivalent in mathematics. So it's actually equivalent to 13. So the hexadecimal number is actually D, but it's equivalent to 13. Check this out. Yes, it can be small or capital. No problem. Okay. Yes. Now, I don't know whether I told you, we have 2 versions of IP, isn't it? The first version is version 4. Okay. Version 4 uses the decimal numbering system. But version 6, which is the other version of IP, now uses the hexadecimal numbering system. Okay. And the version 6 and MAC addresses. I've talked to you about MAC addresses, but we'll talk more about it in our next class. MAC addresses, which is the physical address, together with IPv6, they are the only 2 addresses that use the hexadecimal numbering system. Others, version 4 uses the decimal numbering system. So, what I want to teach you right now is we want to convert from hexadecimal, and I'll show you just more slides and that's it. So we want to convert, and before I do the conversion, by the way, I need to take you through this one so that you get to know how IP version 6 addresses work out, because it's the future of networking, and so we must be able to get to learn it. So hexadecimal numbering system. Here we go. So check this out. Okay, let me see if I can zoom it in. All right. Okay, yes, this one. Now, I want you to look at IP version 4 is divided into how many sections? Huh? 4 parts, isn't it? And we are called them octet. 4 octets. IP version 4 is divided into 4 octet, where we have first octet with 8 bits, second octet with 8 bits, third octet with 8 bits, and the fourth octet with 8 bits. Are we together up to there? Yes. Each octet is separated from the next octet using a dot or a decimal, isn't it? Yes. And we said each octet was having how many bits? Huh? If you hear the word octet, how many bits? 8 bits, isn't it? And the total number of bits was, if you add all the 32, 8, 8, 8, 8. Total is 32. I'm saying that because I want us to look at how IPv6 is. Number one, in IPv6, there are not 32 bits in total. In IPv6, there are 128 bits in total. Are we together? Are we together, guys? In IPv6, there are 128 bits in total. The other difference is this. In IPv6, we don't have 4 parts, 4 octets. No. In IPv6, we have 8 parts. Okay? I want to take those points slowly by slowly. In IPv6, we have a total of 8 parts. And the 8 parts in IPv6, they are not separated with a dot or a decimal. No. They are separated with a what? Not a semicolon, full colon. Okay? They are separated with a colon. Just circle one there. The 8 parts are separated with a colon. In IP version 4, each part is called an octet, isn't it? In IPv6, each part is given a name that is not yet official, but the name is hextet from hexadecimal. Then the name is hextet, but the name is not official yet. So in IPv4 is octet, in IPv6 is hextet. Hextet. I'm getting to the most difficult part now. So we have already said in total bits in IPv4, 32. Total bits in IPv6, 128. Very good. In IPv4, each part is called octet. In IPv6, each part is called hextet. Hextet. In IPv4, the parts are separated with a dotted decimal, isn't it? In IPv6, the parts are separated with a colon. Now we want to find out, why do we call each part in IPv6 hextet? That's what we want to find out. And that is going to tell us each part in IPv6 has how many bits in total. Sawa? Good. So let's check up here. Let's check up, and I'm going to take you back. I'm going to take you back because I did something. I'm not sure whether you saw it, but I did it. So I'm going to bring my notepad again. We got 5 here, isn't it? When you wrote 5 into bits, you got how many bits here? How many bits are these ones I've highlighted? 4, isn't it? Because in IPv6, we used 1, 2, 4, 8, which are how many numbers? 4, isn't it? In IPv4, there were 8 numbers, isn't it? It was 1, 2, 4, 8, 16, 32, 64, 128. There were 8. In IPv6, we only use 4, which means at any time you write any hexadecimal number, it will always get 4 binary bits. You'll always get how many bits? 4. Even if we just took 5, and we got 0, 1, 0, 1. We took D, which is equivalent to 13, and 13 is 1, 1, 0, 1, isn't it? Okay? What is happening here? Okay. Ooh. There is a problem. Oh, it's back. Okay, check this out. Give me any other number among the hexadecimal numbers. We have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. Give me any of the numbers. People online are suffering. Seriously. We're trying to get you back to the meeting. Okay, thank you. So, give me this one. Give me any other hexadecimal number. I need to write them here. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, 0, sorry. So A, B, C, D, E, F. It's a very big problem here. I don't know why it's happening. Okay, so can you see these are the hexadecimal numbers? Yeah, and it's a network problem here, and these guys are going to. Yeah, I want you to see them. You'll say I didn't show you. 12, 13, 14, 15. You can see them clearly now, isn't it? If you look at my board, you can see all the hexadecimal numbers, isn't it? Yes, and you said A is not 10, but A represents 10, okay? Because we are just from 9, A is 10, B 11, C is 12, D is 13, E is 14, and F is 15. Are we together up to there? So what I'm saying, can you give me one of the hexadecimal numbers? That's what I'm saying. Just give me one. Which one can we pick? We take B, isn't it? Yes. People who are online are having serious suffering. Let me just put my hotspot on so that in case they will have a problem, they'll got it. Anyway, so let's take B. B represents 11. So let's put, guys, let's put 11. 11, which numbers, if you add there, you get 11. 8 plus 2 plus 1, because 8 plus 2 is 10, plus 1 is 11, isn't it? So put 1 under 8, put 1 under 0 under 4, 1 under 2, and 1 under 1, isn't it? Yes, 1 under 1. It's playing so much. Okay. So anyway, let's see this out. So 11 will be 1, 0, 1, 1. That is equivalent to 11. And okay, I think that's okay, just so that we finish up. Okay, so this is gonna be B, and you can write them in small letters, or you can also write them in capital letters, okay? So have we agreed? One thing we have agreed, any hexadecimal number will give us how many bits? Hey, how many bits? Any of them will give us 4, isn't it? Very good. That's what I wanted to hear. So let's go here. So here, right here, from what we have already said, we have taken, let's say we take, because in each and every hexstat, please look up. These ones are the 8 hexstats. These are the 8. So let's say 4 zeros. By the way, okay, let's say we have 0, 0, 0, or the F, 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 F. These are the 8 parts here. Those are the 8 parts. Now listen to this. Next thing, every hexstat has 4 hexadecimal numbers. I've not talked about the binary, okay? Every hexstat has how many hexadecimal numbers? 4 hexadecimal numbers, okay? But each hexadecimal number can give us how many bits? You have not seen it. I want you to see it. See it. Every hexadecimal number give us how many bits?
4 bits.
4 bits. We have just written 13, 11, and F and D, isn't it? Any of them, even if you get 0, you'll get 4 bits. So any hexadecimal number gives us 4 bits. But now, in each and every hexstat, we have 4 hexadecimal numbers. It can be 1, 1, 1, 1. It can be A, 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 A. It can be B, 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 B. It can be A, B, C, D. It can be 1, 2, F, F. But each hexstat, each part of the IPv6 has a total of 4 hexadecimal numbers. But if you write each of the hexadecimal numbers, for example, if you write F represents 15. 15 in binary will give us 1111, because all the numbers added, you get 15, isn't it? 8421. That means if you take the first F here, we write in binary, we'll get 4 ones, isn't it? Good. We take the second F here, it will also give us 4 ones. You take the third F here, it will also give us 4 ones. You take the last F here, it will also give us 4 ones. Can you see that? Good. Even if you take these zeros, we have 4 zeros here. If you take the first 0, you get the 4 zeros here. You take the second 0. You take the third 0. You take the fourth 0 here. Okay? Which means, check this out. If you take just one hexadecimal, which has 4 hexadecimal numbers, and each of them will give us 4 bits, which means if there are 4 hexadecimal and one of them has 4 bits, what is the total number for the 4 of them? It's like 4 times 4, isn't it? Which is
16.
16. 16. No wonder we call it a hexadecimal, because each hexadecimal has a total of 16 bits. Are we together? Yes. Each hexadecimal, even if you wrote this one into bits, we'll get 16 bits. We wrote this one, we get 16 bits. We get this one, get 16 bits, because every hexadecimal has 4 hexadecimal number, and each of them has 4 bits. So each hexadecimal has 16 bits. That's why it is called a hexadecimal. Okay? My question is this. If we have 8 parts, 8 hexadecimal, and one hexadecimal has 16 bits, what is the total number of bits in all the 8 parts? 128. That is how
120.
IPv6, exactly. IPv6 has a total of 128 bits. Did you know that 128 divided by 32 is 4, which means one IPv6 carries 4 IPv4 addresses. You get that? Because IPv4 has a total of 32, isn't it? But IPv6 has a total of 128. 128. It's like an IPv4 goes into IPv6 4 times. So the length of IPv6 is a bit larger, it's 128 bits, but the length of IPv4 is just 32 bits. I wanted us to get to know that. We'll meet this one again in chapter 12. But the other knowledge we'll meet it in chapter 11, soon and very soon. Let me take you through the next part very fast so that we get going now. And the next part will take us just a few minutes and we will be out of here. It was important that you know those particular, you get that knowledge. So, I need to get my notepad so that you understand it. So, check this out. Oh, sorry. I'm gonna remove these ones. So to change, listen to this. To convert decimal to hexadecimal, listen to this. To convert any decimal number to hexadecimal, you must go through binary. Are we together? You must go through binary. So from decimal to hexadecimal, you must pass through binary first before you can go to hexadecimal. The same way, from hexadecimal back to binary, you must still go through from hexadecimal to decimal, you must also go through binary. And that's what I want us to do right now. We are given a number here, 168. We are given a number here, 168. 168. Check this out. Let's check this. So you pass through what we did first today. Okay? So let's do this. 168, we must first write it into the 8 bits, the one we did first today. So my question is, 168, which numbers, if you add here, you get 168. So the first one is 128, isn't it? So 120, what is 168 minus 28? 40. 40 is actually 32 plus 8, isn't it? Yes, which means all these ones are going to be 0. This is 1. This is 0. This is 0. Oh, 8 should be 0. No, see, 32 plus 8. Yes, it should be 1, isn't it? So 128 plus 32 is 160, isn't it? 160 plus 8, 168, isn't it? Which means our binary is 101001 000. This is the binary we have gotten, isn't it? Yes. What do we do with it? The next step is this. Ladies and gentlemen, the next step, wait a minute. The next step is as follows. This my notepad works well for me, better than using the whiteboard. So once you've gotten that, the next step is this. You now, of all the 8 bits, you separate them into 2 equal parts. Are we together? Okay? Separate them into 2 equal parts. And so the first one is going to be this one, which is going to be, we put it here. So this is going to be 10, 10, 10. Did you understand this part? You get the 8 of them, then divide them into 2 equal parts so that they are 4, 4. Okay? Once you get the 4, 4, we now put them back into this other smaller scale of 8, 4, 2, 1. What is this going to be? If you add those numbers, what do you get? You add where there's a 1. Very good. It will be 10. 10 is which hexadecimal number? 10 is A, isn't it? Good. Let's take this, the other one, the remaining one. You also put it here. What is this going to be? Is it equivalent to?
It's 8.
It's going to be 8. And 8 is which hexadecimal number? 8 is just 8. Very good. 8 is just 8. So, ladies and gentlemen, your hexadecimal number, the last answer is very simple. The last number, so hexadecimal of 168 is equal to A8. Is that okay?
Yes.
Yes, we just get A8, A and 8. That is your hexadecimal number. That is how you convert from decimal to hexadecimal. You must pass through binary. So you first get the 8 of them, separate them into 2 equal parts, put them to the scale of 8, 4, 2, 1, separate them, and get the first hexadecimal, get the second hexadecimal, put them together, and you're good to go. Is that okay? So if I give you an example, you'll do, isn't it? Let me now give you from hexadecimal back to decimal. Okay? Can we do one? Yes, let's do just one. Just one hexadecimal back to decimal. We are actually given D2. So I want to modify the one that is here. Can I? Can I modify the one that is here? Because we start from down going up now. Okay? Can I? Yes. So this is now going to be D2. That is our hexadecimal. We now want to work backwards. Okay? So D2 means this answer currently is not there. So it's we put a question mark there. So D2 means we need to put D here, isn't it? That is D. And this one is 2, isn't it? D normally represents which number? Very good. D is 13. And 2 is just 2, isn't it? No. 13 is what plus what? 8 plus 4 plus 1. And so 2 is going to be 0. Is that okay? What about 2? So 0, 0, 1, 0, like that, isn't it? Good. Now we are having this is 2 in binary, and this is D, which is 13 in binary, isn't it? Very good. Once we do that, we now want to take it back here. So this is now 1101. So it's going to be 110, and this is going to be 1. And this other is 0010. So 0, 0, 1, 0. So now we come and merge the 8, the 4, we merge them into 8 of them, isn't it? Are we together? Yes. So this is now going to be, here it will be 1. And so it's 110, 1, isn't it? Is that okay? I don't know whether you're following. Are you following? Yes. I'm just replacing these ones. I'm replacing them here. Okay? Yes. So it's now 1, 1, 0, 1, 0, 0, 1, 0. Now you convert this one. It's like we're adding 128 plus 64 is 192. 192 plus 16, 208. 208 plus 2, 210. So our answer here will be 210, 210. And even this one here will be 210. Is that okay? That should be clear now. And that is the end of this class now. Now I just want to give you some assignments to work on. Some assignments to work on. Yeah. Changing backwards and changing forward. So let me go to the assignments to give you that very fast so that we get to go home. We get to go home. All right. So the assignments for you guys is going to be as follows. So the first assignment is 514. The class secretaries, please note down 514 is the first one. Everyone else needs to write as well. 514, 514. Then 516. So 514, 516. Then 519, 519, 519. Then there's this next assignment is 5110. That one, make sure you every day before you sleep or when you wake up, please make an attempt of playing the binary game. You are already, you are supposed to take some money from me, you didn't take them. And you made the offer to expire. I don't know why you people are like that. This very tough economic times, I would have done that. That was not very wise. But anyway, so 5110 is a game. I plead with you, keep on playing it until we get to chapter 11, because it's going to shape your thinking, because the heart of this course is chapter 11 and 12. We call it the last networking math 2. So 5110 is a game, the binary game. Please keep on playing it. The next assignment, guys, next assignment is 525. 525, 525. And the very last assignment for today is 532. 532. 532 is the very last assignment for today. Others, the binary game on 5110 is a continuous assignment, continuous until you get to chapter 11. Otherwise, I think that marks the end of our studies. I have taught it in the best way I can, and I hope that it's going to help someone out there when you'll be getting to learn about this. I'm now stop this recording, and I'll send you the link some other time. Send you the link some other time.